introduce our second presenter, like Arlene Kidd. Arlene is the technical director at Ardmel Group UK, bringing over 2 decades of experience in the technical textiles industry. Throughout her career, she has demonstrated a strong commitment to innovation and production development, contributing significantly to the advancement of high-performance textile technologies. Under her technical leadership, Ardmel Group has continues to uphold its reputation for excellence in quality, functionality, and technological innovation. Arlene has also developed a focused interest in the area of moisture vapor transfer barriers, dedicating several years to the study of breathable materials used in firefighting gear and outdoor apparel. Arlen, I'm going to pass the microphone to you, and please go on ahead. Thank you very much.
Canada, I can't actually see myself on the screen, and my slides are very, very small. Got you. Okay. Can everybody hear me? Yes? Okay.
Yes, lovely. Please go on.
Okay, you can hear me. Okay, good morning, afternoon, and evening, and thank you for being here. Today, I want to draw attention to a serious issue that is completely overlooked in firefighting protection. How so-called breathable membranes used in turnout gear can actually become a pathway for toxins, putting firefighters at greater long-term risk. Next slide. So in this presentation, I'm going to focus on 4 key areas: understanding the risks associated with breathable membranes in fire suits, exploring the pathways of toxic exposure and behaviour of these membranes in fire situations, and looking at the standard in more detail, touching on safer and more protective option that would improve firefighters' health and safety. Next slide. So, why does it matter? Fire suits are engineered primarily to protect against heat and flame, but every layer from the outer shell to the inner linings may contain or allow exposure to toxic chemicals. The long-term health impacts are significant, and studies have shown elevated rates of melanoma, prostate, bladder, and testicle cancers among firefighters. In the US, firefighters are 9% more likely to develop cancer and 14% more likely to die from it than the general public. And here in the UK, 4%, which may be higher, of firefighters report a cancer diagnosis compared to just 1% in the general public. These statistics clearly demonstrate that firefighting is not only physically dangerous in the moment, it also carries serious occupational health hazards that can develop over time. Next slide. So most of us are familiar with the basic materials that make up the ensemble of the current firefighters' PPE. Aramid fibers like Nomex and Kevlar, thermal liners and moisture barriers. But the issue isn't just about heat resistance, it's about how these layers interact with one another during real-world fire exposure. Next slide. So PFAS, which again we're all aware of, one major concern is the widespread use of PFAS, also known as forever chemicals. These substances are used in turnout gear for their water, oil, and stain resistance. However, PFAS are highly persistent, meaning they don't break down in the environment or in the human body. While they offer functional benefits, their long-term presence raises serious health concerns, especially when combined with the extreme conditions firefighters work in. Next slide. So studies have shown that just a 5% increase in skin temperature can lead to a 400% increase in the absorption of toxins through the skin. This highlights the critical importance of maintaining effective barriers between the skin and external contaminants, especially in high heat environments. Next slide. Sorry for the gruesome one. Protective gear must protect. Firefighter suits are designed to save lives, not endanger them. Protective gear must shield firefighters from harm, not become another source of risk. Firefighters already face extreme hazards in the line of duty, and their suits should not contribute to the danger they're willing to face. Next slide. So the real risk. So looking at the absorption of toxins through breathable membranes. So to understand the risks, we need to look more closely at the standards used to evaluate breathability in fire suits. You might ask, why question international standards, especially those set by experts? And the answer is simple. Standards exist to ensure quality and safety. But when a standard may itself be flawed or outdated, we have a responsibility to question it. The ISO 11092 standard is one such example, and it is applied globally across firefighting PPE, making it a common denominator in gear performance. Next slide. So let's examine the test conditions. So before accepting the standard as fit for purpose, it's important to understand what conditions it's actually testing for. Next slide. So the ISO 11092 test was originally developed to measure vapor permeability in outdoor recreational garments, not in extreme life-threatening environments like structural fires. Yet somehow it has become embedded within the PPE standards for firefighters' clothing, a surprising and questionable transition given the very difficult conditions involved. Next slide. So real world heat versus lab conditions. Here we can see the temperature firefighters actually face on the fire ground, often exceeding 600 degrees C at a ceiling level and up to 1000 degrees C in a flashover condition. Compare that to the mild controlled lab conditions used in the 11092 testing, and the disconnect becomes obvious. Next slide. So let's look at the limitations first of all. So the test, while widely adopted, has critical limitations when applied to firefighters' PPE. It does not account for radiant heat exposure, which is a major factor in real fire environments. There is no meaningful correlation between the controlled lab conditions of the test and the extreme temperatures experienced during a structural firefighting. It also fails to consider moisture buildup inside the suit or the risk of steam burns, both of which are common and serious hazards on the fire ground. In short, the test doesn't reflect the conditions that firefighters actually face. Next slide. So the concept of breathability is often overvalued and in many cases simply non-existent during active fire situations. In theory, breathability allows sweat vapor to escape, providing comfort, but in a real fire environment, external pressure, heat, and humidity reverse the flow, meaning that instead of moisture moving outwards, hot gases and vapors can be driven inwards directly towards the skin. Next slide. So why breathability fails in fireground conditions? Fire environments are pressurized and saturated with toxic gases, steam, and extreme heat. The membranes used in breathable gear are not designed to resist inward diffusion under these conditions, and as a result, the very feature meant to enhance comfort becomes a vulnerability, allowing harmful substances to enter the protective ensemble. Next slide. So, breathable membranes have several key weaknesses in fire service applications. They rely on moisture vapor gradients, which reverse in high heat and high pressure scenarios. They're often permeable to gases and vapors, especially at elevated temperatures, and they do not block toxic chemicals which can pass through the membrane and be absorbed by the skin. This makes them unsuitable as a sole line of defense in hazardous fire conditions. Next slide. So hot zone challenges present extreme physiological and environmental challenges. Firefighters are exposed to superheated air, toxic gases, and high humidity, all of which push gear to its limits. Heat stress, steam burns, and toxic absorption are very real risks when gear performance breaks down. It's in these moments that every layer of protection must work flawlessly, and any failure in the system can have life-threatening consequences. Next slide. So to explain what actually happens in a fire situation, the diagram illustrates the pathway of hot steam and toxic vapors entering the suit. Because the outer layer lacks a waterproof or impermeable barrier, it creates an open channel for external contaminants to pass through. Once the suit enters a state of inward diffusion, where the pressure and the temperature gradients reverse, the protective function, hot steam vapors and harmful toxins are able to pass through the membrane and reach the wearer. At this point, these substances can penetrate the skin, entering the body through its most vulnerable barrier, the open pores. Next slide. So, routes of toxic entry. There are multiple routes through which toxins can enter the body during firefighting operations. These include inhalation of airborne chemicals or particulates, dermal absorption through direct skin contact, and even ingestion in some rare or accidental cases. Our focus here is on dermal absorption, which has been underestimated for too long. Next slide. So whilst the skin, while designed to act as a barrier, is not impervious, especially under high heat, sweat, and stress. When elevated, temperatures open up pores and increase blood flow, and the skin becomes highly absorbent, allowing toxins to pass directly into the body. Next slide. So absorption in the bloodstream. Once these toxins penetrate the skin, they enter the bloodstream, and from there, they can reach critical organs, build up in fatty tissues, or cause systematic health effects, including cellular damage or carcinogenic impact over time. This makes it even more crucial that gear truly prevents exposure at the surface level. Next slide. So this is just one example. There are lots of papers that have been written on the subject. I've highlighted just one published in the Journal of Environmental Research, in which the study confirms that toxic compounds are capable of penetrating through the firefighter's PPE, particularly in high heat conditions. This underscores the need to rethink material choices and protective strategies, not just rely on standards that don't reflect real fireground conditions. Next slide. So reducing the risks. So recent research strongly emphasizes the importance of decontamination in minimizing post-fire exposure risks. While decontamination is essential, it is not a complete solution. To truly protect firefighters, we need to go beyond current practices and address deeper vulnerabilities. Next slide. So despite its critical role, decontamination offers limited protection against toxins that have already been absorbed through the skin during active fireground operations. Once these chemicals penetrate the body, decontamination really has no effect. Next slide. So we do need better alternatives and safer alternatives, and it's clear that we need them now. The goal is simple, but it's urgent. Reduce the number of firefighters at risk of developing cancer due to occupational exposure. Next slide. So there are probably lots of options of how industry can work at overcoming some of this phenomena. So I'm just touching on one, which is using and going back to basics of using non-breathable impermeable barriers. And this is basically because breathability does not work in a fire situation. So the whole argument of comfort goes out the window. Once a guy is hot and he's sweaty, he's hot and he's sweaty, and that's that. Nothing is going to stop that. But what we need to do, and is critical, is to address the critical issue of what the phenomenon that's happening of reverse breathability. And by adopting non-permeable layers, we can effectively eliminate the phenomena and stop toxic vapors from penetrating into the suit under high heat and pressure conditions. Next slide. So a mindset shift is needed alongside a radical overhaul of standards if we're serious about protecting firefighters' long-term health. The goal must be more than just compliance, it must be prevention. For me, this is personal. I'm committed myself to developing or looking at more ensembles that will bring cancer risks for firefighters down to a level of the general public. No firefighter should face a cancer diagnosis simply because of the gear meant to protect them. In my opinion, this is a huge failing, and I cannot believe that this issue is either being swept under the carpet, ignored, or just not known for such a long time. I think with standards, we adhere, we comply because we don't question. But as I mentioned before, when it becomes a major issue that could be the underlying problem, then it's only in our best interest, if we're going to improve things for the firefighter going forward, that these are addressed. So that is my total of the talk today. So thank you very much for listening.
It is great. Thank you very much, Arlene, for such a nice presentation and nice topics to share with all of us.